Imagine if you could look back to an era when the universe was still in its infancy, and thus to a time when the first stars illuminated the darkness of space with their light. James Webb takes us on a journey to the first stars of the cosmic dawn, but what do we see? Since the beginning of our universe is no longer just theories and calculations, but has become a tangible reality, scientists have had to accept unpleasant truths. Everything is completely different from what we have long imagined. The James Webb Telescope was named after one of the architects of the space age. James Webb was one of the first heads of NASA in the 1960s, and among other things, brought the Apollo program into the world and thus the first men on the moon. The new telescope is not only a milestone in technology, but also a key to the secrets of the early universe. With its special ability to look into the furthest corners of the cosmos, Webb takes us on a journey to the beginning of time, at least, that's what researchers thought. And then everything turned out quite differently. Webb's initial findings are groundbreaking and show us that we may not have fully understood the beginning of time and the cosmic dawn. Imagine traveling with Webb back to the beginning of the universe, to a time when everything was supposedly still dark, silent, and empty. This is said to have been the era before the first stars were born, before the first galaxies were formed, and before the first light was emitted. Researchers have so far dated this period of cosmic dawn to around 100 million years after the Big Bang. But at this point, or let's say a little later, you don't see darkness in a universe that shows signs of early evolution. You see only perfection and beauty, as if there had never been anything else. To understand the fascination of Webb's findings, we need to understand how astronomers have explored this age of the universe and how they came up with their theories and descriptions of this time. All knowledge about the evolution of the cosmos has so far been more theoretical than practical. About 100 years ago, two researchers named George Lampt and Edwin Hubble observed the movement of galaxies. They noticed that they were drifting apart. Put simply, this first gave Lampt the idea that the universe originated from a single point and has been expanding ever since. When Albert Einstein presented his calculations about matter and its movements and all known physical forces in the observable universe, researchers took Hubble's and Lampt's observations and the rules of general relativity and then calculated the universe backwards. As a result, researchers were fairly certain that they knew roughly what had happened during and after the Big Bang. The discovery of cosmic microwave background radiation seemed to further confirm these ideas. But no one had seen these events until recently. Imagine, once again, that you are a researcher and are eagerly awaiting the first images that finally show what you have spent a lifetime calculating and imagining. But the images show you a completely different cosmos. How would you react? You could be disappointed and shocked, or you could be excited and joyful, and open yourself up to what is really there. The latter is currently very difficult for some, especially the conservative branches of science. But other young and open generations of researchers see this dawn of truth as an opportunity to finally understand much more about the universe. The first stars didn't exist. So now scientists are looking for the first stars, and they are finding stars that are completely different from what they have assumed for decades. The first stars are extremely difficult to find. Their light is very faint, and the expansion of the universe shifts what little light there is strongly into the red range. This is where the ingenuity of the James Webb Space Telescope comes into play. The most powerful and ambitious space telescope ever built is equipped with sensors so fine that it easily captures the infrared light of the most distant and oldest objects in the universe and shows us galaxies that must have been the first after the Big Bang. But these galaxies are so large, so perfectly organized, and so full of shining stars that they cannot possibly be the galaxies of the cosmic dawn. In the beginning, only a few misshapen globular clusters are likely to have existed. They should have contained the legendary stars of population 3. Although these were bright and luminous, they only had a very short lifespan. However, Webb shows us galaxies that already contain very old stars, so something can't be quite right here. By discovering the real first stars, Webb can now help us to really understand the early history and evolution of the universe. His observations will replace all theoretical models and simulations of the first stars. At the moment, a dispute has flared up, and some scientists are fighting tooth and nail against the new truths. They are desperately searching for explanations and want to hold on to their old theories. But what if those first stars simply didn't exist? What if the universe is much older or possibly never had a beginning? What if researchers like Lampt and Hubble were simply wrong? How did the first stars really form? Can you imagine an infinite universe in which stars have simply always been there? This is difficult for us humans because we are used to thinking in dimensions that presuppose a beginning and an end. The idea of infinity or scenarios that lie beyond our mathematics, our numbers, or physics is difficult or even completely impossible for many people. Even if stars have always been there and there was never a beginning in the form of a Big Bang, there are, of course, star formation processes. New stars are constantly being formed in the cosmos, and old ones are passing away. Stars are formed from huge clouds of gas and dust. Scientists refer to these structures as molecular clouds, which consist mainly of hydrogen. Under the influence of gravity, condensations take place in these clouds, which eventually generate such immense forces that a star is born in the center. When a region in such a cloud reaches a critical density, it begins to collapse under its own gravity. This process increases the temperature and pressure in the core of the cloud until conditions are hot and dense enough to allow nuclear fusion. And this is when the star's light appears. Initially, stars are still shrouded in dense clouds of dust, and their light is difficult to penetrate. But the cloud clears, and planets can form from the remaining materials. Sometimes the forces are even sufficient, and a second star forms. This creates a binary system. It's estimated that there are over 100 billion galaxies in the universe as we know it today, and each galaxy is home to billions of stars. This incredible number of stars shows how ubiquitous and essential star formation is to the universe. Stars have different lifespans depending on their mass. We have these findings from current observations, and so they are certain. The ideas about the beginning of the universe and the formation of the first stars in the cosmos, on the other hand, were not certain. We have only been able to observe this epoch with our own eyes since the launch of the James Webb Telescope. James Webb's impossible discoveries, it sounds crazy, and yet it's true. It was a single image from the new telescope that turned the world of science upside down. James Webb's deep field image shows some very close and bright galaxies in the foreground. It gets exciting from the point where the galaxies become fainter and glow orange or reddish because these are the oldest galaxies. This is exactly what researchers wanted to see, and the excitement about the clarity of the image was enormous. At first, everything was fine. Then the astronomers and cosmologists set about analyzing the image data and found galaxies so old that they shouldn't actually exist. The Harvard astronomer Rohan Naidu announced the sensational find shortly after the publication of James Webb's first image. He had tracked down a galaxy with a redshift of Z = 13, and that is a real universe breaker. Z13 means nothing less than that this galaxy already existed 300 million years after the Big Bang. Do you remember that researchers assumed that the universe was completely dark until 100 million years after the Big Bang? That leaves 200 million years in which this galaxy, called Glass C13, could have evolved, and that truly blows all of our theories of star births and galaxy evolution out of the water. It would be like looking into a baby carriage and seeing the face of an adult. Glass C13 was not alone. Shortly afterwards, another team of researchers announced the discovery of a galaxy with a redshift of Z = 16.4, which would make this galaxy even closer to the Big Bang than Glass C13. Both galaxies are not just any loose globular clusters, but beautifully shaped galaxies that presumably contain many stars of all ages. Sears 1749 shocked the researchers, and of course, the results were checked several times. The second measurement of distance and age gave a redshift of Z = 5. The confusion was perfect, and the surroundings of this galaxy provided further confusing data. It seems that Sears 1749 exists in two places at the same time, which earned it the nickname Schrödinger's galaxy. Opinions are still divided on Sears 1749, and neither of the two measurements has yet been confirmed with certainty. However, the age of Massey's galaxy has been confirmed without a doubt. Together with Glass C13, it was declared to be one of the two oldest known galaxies. Sears 212 is not quite as old as these two, but this galaxy, which exists at around 900 million years after the Big Bang, shows another anomaly that should not exist if the Big Bang had occurred as previously assumed. It would have been at most 700 to 800 million years old at the time it emitted the light that has now been collected by James Webb. However, Sears 2112 is almost an exact twin of the Milky Way, slightly smaller and slightly fewer stars, but very similar in shape. Until now, researchers were certain that it takes billions of years to form a beautifully shaped barred spiral galaxy. And this one would only have taken a few 100 million years.